Our next set of slides is going to be all about collecting data and making graphs. Although we're going to pretty much try to centralize on histograms and circle graphs, I certainly wanted to at least touch base on a review of what some bar graphs and line graphs are. Remember that this set of this unit was meant to be 8th grade review of material that you learned in 6th grade. So let's use it as a review, but I'm sure that many of us have forgotten many of these things, so we review them. A bar graph. What is a bar graph? That's when data is organized into categories. They're at one point in time. A survey on one particular question, perhaps, what is your favorite color today? It's not when something that happened long ago. It's one point in time. You can have a double bar graph. In a double bar graph, you have two sets of data. In this case, you're going to need a key because you're going to have two different color bars. Two data sets, and each one will have their own color. Let me go back and remind you, though, that when you are doing a bar graph, it is all one color. Often I find a textbook does a bar graph and they pick all these rainbow colors and every single bar gets its own color. Okay, that is not correct. You have to have a bar graph with one color. Otherwise, you would need a key to know what the colors mean. So we will have a bar graph with one color, a double bar graph with a key and multiple colors. Line graph. Here's the big difference. A line graph changes over time. This is when you're going to say, how much money did you make over the last 10 years? What did the stock market do over the last 10 years? You are not looking at what has happened today. You are looking at what happened over time. You can have a double bar graph, and you can relate two different lines. You can have boys and girls, and maybe boys and how tall they are over time, or girls how tall they are over time. And you can compare two things over time, and you can use two colors. The circle graph. The circle graph is by far the most complicated. When you have a circle, you are showing 100% of the data. So each portion of the circle, when put together, has to equal 100% of the data, as you see here. So in this example, we have different types of sneakers that somebody could buy. Adidas, Nike, Reebok, Asics, other. I do, as my example, 150 people bought Adidas, 192 bought Nike, 60 bought Reebok, 108 bought Asics, 90 bought other. You must add up the total of numbers sold. Often they do not give you that information. So if you're getting just data of items sold in a variety, you have to have a total. Now, we need to know what percent each brand was of the total. Hopefully all of us remember that the word of means multiply. And if we're going to do percent of total, you can either do a division problem because division is related to multiplication. And in this case, that is exactly what we're going to do. We're going to set up ratios. 150 out of 600 equals 0.25. Converted to a percentage, 25%. 192 out of 600, 0.32, 32%. 60 out of 600, 10%. 108 out of 600, 18%. 90 out of 600, 15%. You must be careful and you must realize that your percentages have to equal 100%. If they don't equal 100%, you are not going to have a complete circle, or you're going to have too much data for a circle. That means you might have to do some rounding because this has to equal 100%. Now the percentages are just what you use to label each section of the circle. As you can see, making a circle graph is getting much more difficult than you expected. You now take that percentage, and we all know that a circle is how many degrees? We know a straight line is 180 degrees, so if you take the top of a straight line and the bottom of a straight line, you get 360 degrees. I need 25% of that circle to be Adidas. Again, the word of means multiply. 25% written as a decimal, because we all know that percentages are not allowed in equations. You must convert to a decimal. 0.25 times 360 degrees, 90 degrees. So when I go to make my circle, I am going to start with my first section being 90 degrees. I repeat this process. 32 degrees, 0.32 times 360, 115.2 degrees. And I do that for each portion of the circle. I suggest you pause the video if you want to try to calculate these equations yourself. And I see that I have a mistake here, and this should be a multiplication sign, not an equal sign. My regular students, you know that you're used to me doing this all the time. So let's move on to what the actual circle is going to look like. Here's our circle. Sneakers sold in November. I started with my Adidas 25%. I took my protractor, and I have to start where Adidas ends, and I put the 0 of my protractor here. Once I put the 0 of my protractor here, I can do my degrees for Nike. Let me go back. How many degrees was Nike? Nike was 115.2 degrees. So I would have a protractor, and I would use those degrees to make my next section. The important part is that you have to start at the end of the last part that you did, the last segment. You have to start here and use your degrees. By the time you get to the end, remember, you will have 360 degrees and your percentages will add to 100%. Notice, you start at 0 degrees and you move around the circle graphing the degrees, but you label the percentages, not the degrees. Circle graphs are not easy. They are multiple steps, so it's going to take you time. Feel free to pause the video, but better yet, hold on, because I have an example for you. So my class knows we like to do an example before you sneak ahead and look at the next slide. I have an example here for you. Coca-Cola, Pepsi, IBM, Exxon, and General Motors. And here are the number of shares that a company might have. You should notice that the total is missing. So you need the total before you can start doing 8 out of total equals percentage. Percentage times 360 equals degrees. I would like for you to try to fill in this chart the best that you can. Pause the video, write it down. After all, we're doing some E-line work, so that requires you to stop and actually do an example. So part of your lesson would be stop now. When you are ready, we're moving on. Here are the answers. I took each number of shares divided by total. Again, I see I made a mistake. This would be 50, not 150. My percentages are correct, however. My percentages will add up to 360, my degrees will add to 360 degrees. My percentages will add to 100%. So I know that I have accounted for everything. It's all there. I can now graph. I do not have an example of the circle graph for this one, but I suggest that you take a protractor and you go ahead and try and draw your graph, color it in, and consider it part of the assignment. So just when we thought circle graphs were hard, things are going to get a little more complicated because here come, oh, my mistake, we're going to be easy, the frequency table, which does lead us into my next type of graph, but sorry, frequency table, a way to organize data. You've all done these a million times, all the way back to kindergarten, where you made a chart and you went around and you asked everybody, what's your favorite ice cream? You made tallies, and then you added up the tallies. The tally column is not mandatory, but it is useful. So I suggest that you keep the tally column if you're ever doing a survey, because you're going to want to have that tally. Here we go. I'm sorry for before, but now we are finally at histograms. A histogram uses a frequency table. So what we just saw, a frequency table. The histogram will use that frequency table to collect data. A histogram is a bar graph where the bars touch each other and use only equal intervals instead of individual values. That's where the problem begins, right here. Using intervals. Example, 0 to 9, 10 to 19, 20 to 29. The problem is 0 to 9 has 10 data points, not 9. Do me a favor right now and count on your fingers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And you will see you have just used up 10 fingers, 10 data points. You cannot use 10 to 20, 20 to 30, 30 to 40, because they will repeat. If I have a value of 20, how will I know which category to put it in? Example, money spent on school supplies. 0 to $9, 10 to 19, 20 to 29, 30 to 39. Each interval is $10. So I walk around and I ask families, how much did you spend on school supplies? And I tally my results. I add up my tallies and I get my frequency number. From this frequency, I can graph my data. Let's look at what the table looks like. I already have my intervals, so I label them. 0 to 9, 10 to 19, 20 to 29, 30 to 39. Please remember that you need an axis label, dollars. Up the y-axis, I have number of people. That was my frequency. So I graph 0 to 9, 2 people. 10 to 19, 5 people. Do you notice that the bars are connected? I only have that yellow or orangey line in between for you to see that it's a separate bar, but they are touching each other. A regular bar graph has space. A histogram does not. You go ahead and you label each section separately using the frequency value. Here's a more complicated example. And of course, this is the type that you would actually get on a test or the IAR, whatever standardized test you're going to take. They're going to give you a set of data. To begin with, notice that the data is not even in numerical order. The hardest part, setting up equal intervals, and you do that by using the range. Look at that word range. We all recall that the word range means the difference between the smallest and the largest value in a data set. This, of course, is different than the second meaning of range when we had XY tables and all the Y values, the Y data set was called the range. The X data set was called the domain. We remember that from our linear equation section. But for right now, we're using the original definition of range that you've known for a long time, which is the difference between the smallest and the largest piece of data in the data set. I have 365 as my smallest, 505 is my largest. Clearly, it helped to underline them. I am telling you, although in a normal situation, you would have to decide, how big should I make my intervals? How many bars do I want? How many intervals do I want? I am telling you in this situation, we're going to use 30-minute intervals. Also going to say to you that we're going to start a little bit under my smallest range because I want a little bit of room for wiggle room. You could start exactly with 365, but if you continue to collect data, you wouldn't have that option then to add anybody. But you could start with 365 and go exactly to 505, but you can see those numbers will be harder to work with. So I have chosen to start with 360. I can't just add 30 because I would get 390. Remember, I'm counting on my fingers, and 360 and using 30 data points gets me to 389. This is difficult for you to understand, but you need to take a moment and keep remembering 0 to 9 is actually 10 data points. So 0, like as in 60 to 89, is 30 data points. I can start with 390, 419, 420, 449. Do you notice that there is a pattern? They're all ending in 9. These are all ending in 0. And here's where you actually see the plus 30. Right here in the first half of the data set. You also see it in the second half, the plus 30. You just don't see it right here. At least you don't see it easily. I make my intervals here. I label them. I graph my frequencies, and I'm good. And I now have graphed the amount of sleep, how many minutes, how many people have done each one of these. I would suggest that you take this data and cover this up, start with my data set, and you try to create this frequency table and this histogram and make sure yours looks like mine. But guess what? I have an example for you. Draw a histogram from the data below. Determine equal intervals of 5 hours. So I am giving you the interval amount 5 hours. Set up a frequency table, graph the histogram. Here is all the data. Make it 5-hour intervals. Use the range of the data to determine a starting and ending point. I am going to give you a bit of a hint. Your range is 21 to 56. You can find those values in your data set. And I'm going to say to you, only because if we were in a classroom, I would want us all to have the exact same histogram. You at home obviously could pick your own intervals. Start with 21 to 25 using 5 hours as your intervals. Again, stop the video. Make your histogram. Remember, this is a classroom lesson. I've already been speaking for 18 minutes. You would have stopped to do the circle. Now you're going to stop to do the histogram. We have a good 30-minute, 40-minute lesson that you have now gone through, but it is extremely helpful to you to know how to make circle graphs and histograms. So stop the video, do your work on your histogram, and then check it by putting the video back on, and I'm going to continue to the next slide. Annual hourly delay per driver in 20 cities. Here is another example for you, but this time I've given you the answers. I wish this was on a separate slide, but I did not realize this was coming. So all you can do, and I don't have my screen to black it out. My tool is missing here for people who are in my actual class. You all know that I have a tool that can cover this up, but it is not in my toolbox at home. So that means you could just cover it with a paper. cover up the data that you're looking at and pause my video. I'm going to do it right now. You have hourly delay per driver in 20 cities. There's your data. I'm telling you to go from 21 to 56. Here are your choice. You can either start from 20 to 21. You can start from 20 to 24. Hold on. Let me look and see. Is this the one we just did? It is. I'm sorry. Here are your answers. I'm making a big deal out of nothing. You could have, when you stopped the video and put it back on, you already got this, and this is just the answers to it. I apologize. Here is your tally, your frequency table. Here is your histogram. Notice this big space because there was nothing there. You cannot just push it together and pretend that didn't happen. So leave the space, but all the rest of the bars are touching each other. Take a good look at it and take your time. One last thing. We have something called a cumulative frequency table. In a cumulative frequency table, you have take a frequency table, and the frequency column is added together to create a cumulative column. So I start with 2. I add 2 plus 5, and I get 7. 7 plus 6 is 13. 13 plus 8 is 21. 21 people bought gifts for $39 or less. If I want just one stacked bar graph, I can look at this and go, oh, look, the majority in red here bought $30 to $39 gifts. I don't even need to know the exact number. I can see that it's more than the others. Not the majority, but more than the others. I can see then comes gold, green. So the fewest number of people bought a gift under $9. Stacked bars are very helpful. The very top of your stacked bar would have to equal the sum of your frequencies, 21. When I added 2, 5, 6, and 8, I get 21, and that's where my top bar has to be. Then you divide it up evenly by the pieces. Takes a little effort to do a stacked bar graph with cumulative frequency. You did it long ago. You did this back in 6th grade, so I do hope that you recall all of this, but I hope that you also got a nice refresher. I am done, and I appreciate all of you for watching my video, and I do want to thank Javier for being my first person to subscribe. For only the people that are actually in my class at school would understand that that's actually very cute. So thank you, Javier, and I look forward to doing more videos as we stay home through this time during our 2-week break. Thanks, everybody. Goodbye.